Okay, so this short presentation is about vector databases, Opensearch, Lucene, FAISS, and other tools. So vector databases are becoming very popular. They're used in AI systems for storing and searching embedding vectors. Embedding vectors are used for semantic representation of data, uh, different kinds of data. It may be text, images, audio, and other complex data types. And they enable semantic search, which is search by meaning, not just by keywords. Vector databases are becoming much better at scaling, handle massive data sets, and providing fast query response times. And there are also a lot of open source vector databases. And typical applications are question answering, recommendation engines, image search, fraud detection. So there's a list of some vector databases. So these are the most well-known, popular ones, and there's a little bit more. And this is from like half a year ago when Tyler was making presentation. I made this table for him. This is some links of like most common databases. And this is about indexing vectors for similarity search. This one is very common. Hierarchical navigable small world. Uh, anyway, if I narrow down the list of databases for my own preferences, I have come up with these 4. So first of all, PostgreSQL, it's open source and it has 2 embeddings, PG vector and PG embedding. They use different way of doing similarity. They only support standard flow, which is 4-byte precisions. So vectors will be big. Next one is Milvus vector database. Under the hood it is using FAISS, which is a Facebook AI similarity search framework, which is written in C++. And it supports standard 4 bytes precision. It also has some methods to compress data for storage, but it doesn't have native support for 1 byte precision. Now, Vespa is a very interesting system. Vespa is system like by itself. Internally, it uses tensors, not vectors, and it supports 1 byte precision in int 8, which is integer. Why I am talking about it? Because as people now are trying to put, I don't know, millions, tens of millions, hundreds of millions data points, and you have vectors which have, let's say, 1,000 or 1,500 numbers, and each number is 4 bytes. And if you multiply all this, you suddenly will need a lot of hardware just to run this search. So as we're doing with large language models, we're quantizing the models so we can run it at modest hardware. Same is happening in this world. Anyway, Neo4j graph database. It's a great database, and people now, when they put knowledge data in the database, they're trying to put it as a knowledge graph, and Neo4j graph database is good for that. And about half a year ago, they added similarity search using Lucene, Apache Lucene. Neo4j is written in Java, and Apache Lucene is also Java, so they work together very well. In November, Lucene added 1 byte precision, but Neo4j, as far as I know, still doesn't have it in their documentation in the latest version, so they still don't have it. Yeah, this is Apache Lucene. So Doug Cutting, he lives in California, and he originally wrote Lucene in, well, 25 years ago. So Apache Lucene is an open source Java library designed for text search, and it uses inverted full text index. And it is used by many other systems, like, for example, by Elasticsearch, Opensearch, Solr, and Neo4j, and many others. FAISS, Facebook AI similarity search. Completely different system. It doesn't use Lucene, it's system by itself. It's written in C++, not in Java, with the Python embeddings. It has its own indices, and it's specifically designed to work with dense vectors, like for example with images, not text, although it can do text as well. So FAISS doesn't have native support for 1-byte precision vectors, but it supports product quantization, where original 4-byte precision point vector is decompressed into multiple subvectors, which are quantized down. Okay, so this is FAISS. So I spoke about Lucene, now about FAISS. And FAISS is used by Milvus vector database and Weaviate vector databases and many others. And also it is used by itself. Note about Vespa. Well, I already said a few words. So it does not use FAISS or Lucene. Vespa has its own built-in system for approximate nearest neighbor searches. It's built around hierarchical navigable small world algorithm, which I mentioned before, has its own native support for tensors, not vectors. And well, it's a whole system in itself. Good system. Another new product, Databricks Vector Search. Databricks Vector Search is a vector database. Well, you know Databricks. It's a distributed processing on clusters in the cloud. And now they added transactional support and they added vector search. So you can create, use search index from Delta table, which is files which support transactions. And the index includes embedded data with metadata. Index can automatically sync when the underlying data table is updated. It uses, again, hierarchical navigable small world algorithm for its approximate nearest neighbor searches and the cosine similarity distance metric to measure embedded vector similarity. And these are some links how to create an index and how to make a RAG system using Databricks. I really want to invite somebody who can maybe make a separate presentation just on that, because it seems like it's a good technology to use for big systems. Opensearch versus Elasticsearch. Opensearch is from Amazon, Elasticsearch is by itself, and it's basically the same thing. So the story was that there was Elasticsearch and it open source Apache and everything was good, but then Amazon was selling their services based on Elasticsearch, and Elasticsearch didn't like it, and they sued Amazon, and the result was that they split into two different directions. So Elasticsearch have updated their license to disallow Amazon from using them. And Amazon took their last completely open source version, renamed it as Open Search, and made it a completely open source project. And now we have two open source projects developing in parallel. They're very, very similar. They're both using Lucene. Um, I think Opensearch also uses FAISS as well. Um, they're fast, they're scalable. There is a lot of activity on repositories. Elasticsearch is faster and takes less resources. So both can be downloaded and installed, both available as managed cloud solutions. There is another solution called Chaos Search. Well, they claim to be cheaper and better alternative to use with telemetry and log data. So this is about these searches. So this is example using Elasticsearch from Python. You see from Elasticsearch, import Elasticsearch, you create connection. This is example of document index, and you formulate the query, and you get the response, and you print the response. So it's very similar to how you would work with MongoDB. And there are clients which you can use, GUI applications which you can use with Elasticsearch. So this is examples of the screens. So this is it for this presentation.